The aircraft referred to in open source intelligence and analysis as the JLXX, a product of the Hongdu Aviation Industry Group, represents a multi-role platform whose design, from the airframe to its integrated systems, is a deliberate and calculated response to a complex set of operational requirements for modern and future aerial warfare. Its first flight on October 28, 2025, was not merely a milestone for a new piece of hardware but a demonstrator for a new philosophy in pilot training, tactical flexibility, and strategic industrial independence. The design choices evident in its configuration are a synthesis of lessons learned from previous trainer generations and a forward-looking anticipation of the needs of a modern, expeditionary Air Force and Navy. Beginning with the fundamental aerodynamics and airframe construction, the JLX's design is a study in optimizing for a specific, demanding flight profile. The swept-wing geometry is not merely for high-speed performance but is carefully tailored to provide a gentle and predictable stall characteristic, a critical safety feature for a trainer aircraft where student pilots will inevitably push the aircraft to its limits. The wing's surface is likely composed of advanced composite materials, reducing overall weight while increasing structural strength, which in turn extends the airframe's fatigue life, a vital consideration for a trainer subjected to constant high-G maneuvers and, in the naval variant, the repeated shock of carrier landings. The most visually distinctive aerodynamic feature, the twin-canted vertical stabilizers, serves multiple overlapping functions. Aerodynamically, they provide superior directional control and resistance to yaw, especially at high angles of attack where a single vertical tail can become masked by the airflow over the fuselage, a common scenario during dogfighting training or during a carrier approach. From a technical standpoint, their canted angle can reduce radar cross-section, a beneficial side effect even if stealth is not the aircraft's primary goal. The addition of the twin ventral fins underneath the rear fuselage acts as a stabilizing anchor, damping out any Dutch roll tendencies and providing a stable platform for weapons delivery and sensor operation. The landing gear is a masterpiece of engineering in its own right. The twin-wheel nose gear is not just robust but is specifically designed to interface with a catapult shuttle via a launch bar, while the main gear is strengthened to absorb the massive, sudden impact of an arrested landing on a carrier deck. The arrestor hook is structurally integrated into the airframe's primary load path, not merely bolted on as an afterthought, indicating that the carrier-based roll was a fundamental requirement from the earliest design stages. The cockpit and avionics suite of the JLXX form what is essentially a flying simulator, designed to replicate the operational environment of a fifth-generation fighter as closely as possible. The tandem seating arrangement, with the instructor in the rear seat having an identical or superior field of view to the student in the front, is housed under a single-piece canopy that is likely manufactured using advanced polycarbonate processes to provide exceptional optical clarity and strength. Both cockpits are dominated by large, reconfigurable touchscreen displays that can be programmed to emulate the cockpit layouts of various frontline fighters, such as the J-20 or J-35, allowing a pilot to transition from the trainer to the operational squadron with minimal additional familiarization time. The forward cockpit's head-up display is a wide-area system that can project targeting cues, flight path vectors, and threat warnings directly onto the pilot's line of sight. This is integrated with a sophisticated sensor fusion system. The radar, housed within the distinctly shaped radome, is almost certainly an active electronically scanned array, which provides numerous advantages over previous generation radars. It can track multiple targets while simultaneously scanning a wide volume of airspace, is far more resistant to jamming, and has a much lower probability of interception by enemy sensors. This AESA radar is the key that unlocks the aircraft's advanced training and combat capabilities. Beyond the radar, the aircraft is equipped with an integrated electronic warfare suite, likely including a radar warning receiver to detect enemy radar locks, a missile approach warner to alert the crew of incoming threats, and potentially jamming pods carried on external hardpoints. Its communications systems are secure, data link capable, allowing it to function as a node in a networked battlefield, sharing target data with other aircraft, ground stations, and naval vessels. The propulsion system, believed to be two indigenously developed Minshin turbofan engines, is a statement of strategic intent as much as a technical solution. While specific performance figures are classified, the use of twin engines provides a critical margin of safety for over-water flights and carrier operations, where a single engine failure could be catastrophic. These engines are designed for high thrust-to-weight ratios and rapid throttle response, essential for wave-off maneuvers during carrier landings and for energy maneuverability in air combat training. The move to a fully indigenous powerplant, potentially a variant of the WS-17, signifies a concerted effort to eliminate reliance on foreign engine suppliers, a historical vulnerability in the aerospace industry. This ensures that the production and operational readiness of the JLXX fleet cannot be affected by geopolitical tensions or export restrictions. The capabilities of the JLXX are a direct result of this integrated design. Its primary role is that of a lead-in fighter trainer, the final and most complex stage of training before a pilot is assigned to an operational fighter squadron. In this capacity, it can realistically simulate air-to-air combat scenarios, from long-range BVR intercepts managed by its AESA radar to close-in dogfights using high-off boresight missiles on its wingtip rails. It can simulate complex air-to-ground missions, teaching pilots to employ precision-guided munitions, manage targeting pods, and conduct low-altitude penetration flights. For the Navy, its carrier compatibility allows it to train pilots in the entire carrier qualification syllabus, from catapult launches to arrested landings and field carrier landing practice at land-based facilities. Its secondary role as a light combat aircraft is robust enough to be a primary mission for many air forces. It can perform point defense, border patrol, and counter-piracy missions. In a low-intensity conflict, it is a highly cost-effective platform for close air support, armed reconnaissance, and counter-insurgency operations, carrying a significant payload of guided bombs and rockets while loitering for extended periods, a task for which advanced stealth fighters are economically and practically unsuited. Future plans for the JLXX are extensive and multifaceted. The immediate future involves a multi-year flight test campaign, progressing from basic flight envelope expansion to high angle of attack testing, weapons separation trials, and ultimately, carrier suitability testing aboard a vessel like the Fujian. Concurrently, the development of specialized variants is anticipated. These could include an electronic attack version equipped with more powerful jammers, and potentially an unmanned combat aerial vehicle director variant, capable of controlling loyal wingman drones in future manned-unmanned teaming operations. The strategic plan is for the JLXX to form the backbone of advanced jet training for the next 3 to 4 decades, with a production run expected to number in the hundreds. Its export potential is significant, as it offers a compelling package of modern technology, multi-role capability, and lower operating costs compared to heavy fighters, making it an attractive option for modernizing air forces across Asia, Africa, and the Middle East. In the long-term strategic context, the successful development and deployment of the JLXX completes a sovereign and closed-loop ecosystem for Chinese military aviation, encompassing everything from the raw materials and propulsion to the training of the pilots and the development of operational doctrine, solidifying its position as a fully independent aerospace power.